So we're going to talk about neural plasticity, right? And we're going to talk about it in the context of learning and memory, right? And we can't have a neuroscience or psychology lecture about learning and memory without talking about this guy, right? So I learned about him not as patient HM, right? Because when I learned about him, he was still alive, and so he was anonymous. Now he has passed away, and now we know his name is Henry Mollison. He was born in 1926. He started having seizures, serious seizures, so bad, so frequent that he couldn't hold down a job. So he was desperate. So a neurosurgeon, William Scoville, no relation to the Scoville heat index person, removed Henry's entorhinal cortex, part of its amygdala, and a large portion of the hippocampus. And when Henry awoke, he had forgotten the last couple of years of his life and could not form new memories for the rest of his life. Um, and this is what had been done to Henry, right? So down the bottom here is a normal slide at about the same level as this one, and we can see the hippocampal formation bilaterally there, and here's the amygdala, and the entorhinal cortex is this section along here. Well, I don't think it goes that far. I think it's this bit along here is the entorhinal cortex. And here you can see patient HM's, where we have the very top of the amygdala. I'm going to have to take their word for it. Um, but the entorhinal cortex has been cut about here. And then the hippocampus has been removed, as has part of the amygdala. And so the lateral ventricle there and there is sort of continuous with the outside of the brain. And so from studies of patient HM, we have learned, or Henry, I should say, we have learned an awful lot about the function of the brain, specifically the hippocampus and its role in memory. There's still lots to know, still lots to learn. Now, I'm not going to focus on the hippocampus's role in memory, um, but we are going to come back to the hippocampus a few times. I just want you to get primed to think that memories are stored in the brain, and how could that be done? And obviously the hippocampus is somewhat important in it, but exactly how, that's for another time, right? And so I wanted to actually try and get to the point where I could say this was the first person who proposed that memories were stored in the brain. It was actually very hard, and I still don't not convinced I've done it. So um, Descartes, he was this person who sort of formalized the concept of dualism, that sort of there is a body and there is a mind, and the two aren't super related. Um, then John Locke, who was a big time um, philosopher, came up with this sort of idea that we were born as a blank slate, tabula rasa, and we learned everything. And that was sort of one of his big contributions to philosophy. Now, what we're actually going to see here is I'm going to be talking about philosophers, and at one point I'm going to stop talking about philosophers and start talking about psychology, because one of the interesting things is one of the people I'm going to mention here is essentially the the creator, the differentiator between everybody previous to him who thought about the brain was a philosopher, and everybody after him, well, not everybody, but were psychologists. So, so there were in the late 1700s, there were a lot of the so-called empiricists who basically, if you couldn't test it, if you couldn't, you know, put your hands on it, you shouldn't really start thinking about it. And so David Hume and Immanuel Kant, and they were very close to explicitly dumping dualism, the idea that there was a sort of a mind that existed in a way independent from the body and brain. Though it's worth noting that David Hume did not get a professorship because his ideas were considered too heretical. They went against Christian orthodoxy. They were too close to the line. So it's interesting to know how people like John Locke or David Hume might have thought about things if they had been free to um, say, hey, hang on, I've never seen a soul, you've never seen a soul, you can't point to a soul, maybe such a thing doesn't exist, and it might have, they might have had better ideas about where consciousness and memory um, was generated. So William James, as far as I know, is the first person to clearly state that memories were formed in the brain. He may not have literally been the first. William James is, they say, the father of psychology, the father of American psychology, certainly, right? He considered himself a philosopher, but his students considered themselves psychologists. And he believed that repeated patterns left traces in the brain, um, and that these traces were memories. We go forward another 50 years and we get to Pavlov, right? So Pavlov was a sort of a, you couldn't quite call him a polymath because everything he studied was physiology, but he won the Nobel Prize, but nothing to do with probably what you've heard of him. He won his Nobel Prize regarding how the gut works, right? So he was hugely responsible for understanding how the pancreas works, for instance. But through those experiments, he started to gain insight into this notion of conditioned reflexes, right? Which I'm sure we're all vaguely familiar with the concept of Pavlovian conditioning, that some stimuli that has intrinsic worth, so the unconditioned stimuli, can be paired with a conditioned stimuli, some stimuli that has no inherent worth, and lead to the unconditioned response, what the unconditioned stimuli produces. So the bell ringing ends up causing salivation because the bell ringing was paired with food, where the food directly generates the salivation. Now, him and Lashley, Carl Lashley was the president of the APA and carried a lot of water in American psychology. Carried a lot of water, carried a lot of weight. He was very important. Lashley and a few of his buddies published a lot of articles saying that Pavlov was full of it, basically. I've read quite a few of them, and I still have no idea what Lashley is ultimately proposing. Lashley was sort of famous for a few ideas that kind of the cortex, there were no specific um, there were no sort of specific cortical areas, that the whole cortex acted as one big thing together. And Pavlov referred to the cortex as a mosaic, so a collection of individual bits. It seems to me that Lashley's response to Pavlov was pretty extreme, given if that's his only difference. But Lashley spent a lot of time saying that Pavlov's ideas was junk. Worth, in hindsight, Pavlov was way closer to the truth than Lashley. In fact, Lashley sometimes is used as sort of a example of somebody who got it all wrong. Um, and in thinking about it, I couldn't. I think it's hard to understand nowadays why Pavlov was such a big deal, right? For hundreds, thousands of years, humans had been training dogs and animals to perform tasks with rewards. And yes, the this is not Pavlovian conditioning. Press the lever, get a reward. Rat presses lever. This is not Pavlovian conditioning, but it it could have been, in the sense of it's such a simple paradigm that I feel it could have been used in the same way. What I came to grasp was that basically they had no models of memory formation at all. They had nothing. That's why there's the image of the Simpsons here. They had nothing to work on. So they had no ideas, no concept of even how to approach memory, right? So that's what made Pavlov's finding such a big deal. He said, look, here I have a tool for you to use to probe learning and memory that we've never had before. Even in hindsight, how obvious some of these ideas are, right? I'll just also add the other thing that's interesting about Lashley is a lot of people have this idea of psychologists putting rats or mice in mazes, right? That was Lashley. Lashley was the guy who was doing that, and he was such an important figure that now just what psychologists do, right? Even though nobody's put a rat in a maze like that, for years. And that's how Lashley got to his wrong idea, right? Lashley showed that he could train rats or mice to complete a maze, and when he whipped out bits of their brain, it didn't stop them. Yeah? And so they whipped out, auditory cortex, they could still do it. They whipped out visual cortex, they could still do it. They could whipped out olfactory cortex, they could still do it. Hence, Lashley says, look, none of these bits have a specific task. In hindsight, right, and I think even Pavlov guessed this. He said, well, the rats probably can use any of their senses, to do it, and so when you take away one, they use the others. Okay, so this is the world that Hebb enters. This world where just being able to get a dog to salivate to a bell is a huge deal. There is, we have these ideas of the traces being existing, um, but people arguing about what to me are very unimportant details. And this is what he said. He said, it's sort of in the first quarter of this book, The Organization of Behavior, he said, let us assume that the persistence or repetition of a reverberatory activity tends to induce lasting cellular changes that add to its stability. This assumption can be precisely stated as follows. When axon A is near enough to excite cell B and repeatedly or persistently takes part in firing it, so if cell A takes part in firing cell B, some growth process happens that makes cell A more effective in firing cell B. And he goes further than that, right? That he says, I believe the most probable suggestion is that in one cell could become more capable of firing other is that the synaptic knobs develop and increase the area of contact between the axon and the soma, the dendrites, right? So we say he's not only saying this is a theoretical. If cell A makes cell B fire a lot, then the connection between A and B gets stronger. He's saying, I reckon it's also happening at the synapses, and he reckons the synapses are getting bigger.